In this video, we're going to review some forecasting techniques that are appropriate for horizontal patterns. And we're going to use data file gasoline. So here I have the data file gasoline. In this data file, like we talked about this one, the sales of gasoline usually shows a horizontal pattern, usually fluctuates randomly around a constant mean. So we define horizontal patterns as random fluctuations around a constant mean. So when we're dealing with horizontal pattern, our objective for forecast would be to get rid of the random fluctuations and to get that constant mean that the values are fluctuating around, all right? Because of that, most techniques that are going to be used for horizontal patterns are averaging techniques. And we're going to talk about some of them here. So I'm going to first go with Naïve techniques, which is a very simple Naïve forecast. The simplest forecast. And Naïve, so I'm just going to write down the definition here, Naïve. For Naïve forecast at period T, for Naïve, f of t, f at time t, f at time t is equal to a actual value of sales at t minus 1 period before. So Naïve is, like I said, is the simplest method. It just looks at one period before and then uses the actual value of sales or whatever variable that you are measuring, uses it for predicting for the day after, for the period after. So Naïve forecast for weather is like looking at the weather yesterday and use it as a forecast for the weather today. So that's very simple. The idea is very simple. So, and then the objective here in this case would be to make a prediction for next period. All right. So we have sales of gallon, weekly sales of gasoline in the past 12 weeks, and we want to make forecast for the next week or weeks, right? So I'm just gonna do it for 1 week, but for horizontal pattern, you just get it for 1 week, and then if you wanna use it for multiple periods, you can use the same value because you believe that they're gonna randomly fluctuate around a constant mean. Once you get that, forecast, whatever the forecast might be, you can use it for the next periods. So I'm just going to stop at 13 here. So the forecast for week of 13, using this formula, forecast at week of 13 is equal to actual value at week 12. Very simple, equal week 12. All right, and then, so this is the formula. This is my formula, and you can just drag it up, and that way you get the forecast for period 2 all the way to period 13. And like I said, if you want to make a forecast using Naïve forecast for period 14, it's going to be 22. It's going to stay constant after that, right? This is usually how we deal with periods, more than one period forecast. In the future, we just use the last forecast that we get and use it. We don't change it. We just use that one. All right. Or you can just do this. Forecast at week 2 is equal to actual value at week 1, and then just drag it down. we won't be able to find the forecast, the naive forecast for week 1, because we don't have the actual value 1 period before that. So we have to start at week 2. So that's naive. The next forecast, next forecasting techniques that we're going to talk about, we call it past average. And that is simply the average of all the past observations that are available. So for example, forecast at period T is equal to the average of anything from day 1, from week 1 to week T minus 1, divided by, like, sum of all of them divided by T minus 1. So I can say it's sum of A1, A2, all the way to A T minus 1 divided by T minus 1. So basically the average of A1, A2, all the way to A T minus 1 divided by the number of observations that you're considering, which is simply taking the average of all the past observations. So past average forecast. At this time, I'm going to start from, it doesn't really matter if you want to start at top or from the top or from the bottom. It just doesn't really change anything. So past average is going to be the average of anything that you have before this period. So at week 2, your forecast for week 2 is going to be the average of anything that happened in week 1. All the information that you have before this week was this 17. So average of that is simply 17, or you can just use average of this value. It just changes the format. Let's see. All right, so this is, let me just get rid of the whole thing and do it again. So past average. I just need to make sure that my numbers are, my cells are in, I'm in general format or number format. Just make sure that you have a number format because we're dealing with numbers. Okay, so past average is simply average of past observation. All right, so 17. And next one is going to be average of past 2 periods. So if you're at week 3 and you're making past average forecast, so you need to take average of anything that happened before. So you can do this. And so on. But I'm just, sometimes you may have a lot of rows. You don't want to like type the formula for every single one of them. I mean, if you're just looking for week 13, that would be easy. You can just take the average of all the past observations, and that would be all. But if you want to copy the formula, if you just want to make it a little faster, probably you just need to, in this formula, if I want to drag it up, if I fix B2, the starting point, and by pressing F4 or Command T, we can fix that. And then if I just drag it up, it's going to take care of the formula by itself. So 17 is the average of B2, 19 the average of 17 and 21, and so on. So that's past average. the most effective techniques, these are not really, especially the past average is not, it's not really very common. The most common are moving averages, moving average techniques, and exponential smoothing techniques. So let me just go ahead with moving average. So moving average has a parameter k, needs a parameter. You need to first determine parameter k for that. So moving average, it's usually called k period moving average. So you need to determine k first. K can be 2, of course, can be 1, 2, 3, any integer number, right? 50, 100, 200, and so on. So moving average with parameter k. With parameter k, or k period moving average. It's the average of past k observation, the forecast at each period is the average of past k. If k is, for example, 3, and you want to make a forecast for week 13, you just need to take the average of past 3 observations. If k is 4, if you're looking for 4-week moving average, you just need to take the average of past 4 observation. And it's called moving average because if you're making a forecast for week 12, then you need to take the past 4. And if you're doing it for a week 13, you will drop 18 and add 22 into your forecasting bucket, right? So if you're doing it for week 12, these are the 4 numbers that you need to take for finding the average, moving average for 4 weeks. If you're doing it for week 13, you drop 18 and add 22 into your forecasting bucket. And as the number of k increases, see if k is, let's say 8, if k is 8, if you just do it for week 12, these are the numbers that you need to use for finding the average for week 12. And if you're doing it for week 13, you just need to drop 23 from the beginning and add 22 at the end. So for week 13, this is going to be your numbers, the numbers that you're going to use. And you can see as k increases, the number of numbers that are commonly used in both cases increases, all right? Which means that the numbers, the forecast gets closer and closer to each other. So adding to k, increasing k, will make your forecast smoother. Just think about that. I'll leave that. I just explained it, but think about it for yourself and try to understand the mechanism here. So moving average, it's the average of, I can do the sum and divide it by, let's do exactly the same thing. Sum of f t minus 1 f t minus 2 and f t minus k plus 1. So if k is, for example, 1, you just need to, if k is, for example, 2, that would be, we don't need to really add this. K, t minus 1, t minus 2, all the way to t minus k, sum of all of them divided by k. Sum of ft minus 1, ft minus 2, all the way to ft minus K divided by K, right? So sum of past K observations. So moving average, and I'm gonna take 3-week moving average, and K is just a parameter. It's here in this example, it's given to us, but in order to find the best K, you need to compare different Ks. You need to try it for 3, 4, 5, 10, 20, and then find the best value that gives you less error. So we're gonna talk about it in a different video, but let's just find the moving average here. So I need past 3 observations to make a forecast for each period. So I won't be able to make a forecast for week 1 because I don't have past 3. I won't be able to do it for week 2. I won't be able to do it for week 3 because I just have 2 past weeks. The first week that I will be able to make forecast, moving average forecast, will be week 4. And the formula will be average of past 3 observation because K is 3. If K was 4, I needed to start from week 5 and take the average of past 4 observations, all right? So the average of past 3, and then I just drag it down. That's all. For week 13, my forecast for week 13, if I'm using 3-week moving average, it's going to be average of week 10, week 11, and 12. The value of sales in these 3 weeks, the average of these values, that would be my moving average forecast for week 13. If now, instead of K3, if I'm using K moving average, K equal 4 or 5. Let's just focus. Let's just make it simple. K equal to 4. Again, I need to use average of past 4 observations. The first period that I can do it would be period 5, and I just need past 4 observations, and then just drag it down. All right, so now this is the moving average. The next method is called exponential smoothing. This one also needs a parameter. We need to determine alpha smoothing factor. So exponential smoothing. In this method, forecast at period T is going to be a weighted average. And in this weighted average, we need a factor alpha that is called smoothing factor. So smoothing factor alpha times A actual value at T minus 1 period before, the actual value of sales 1 period before, plus 1 minus alpha times F of T minus 1, forecast at 1 period before. So here there are 2 things. First, we need to determine alpha. So alpha will be a parameter that needs to be determined before you can find the forecast. All right. So that's one thing that we need. The second thing that we need, as you can see from here, from this formula, every forecast needs, by definition of this formula, every forecast at each period, we need to know the forecast at 1 period before. So for making a forecast for week 13, you need to know the forecast at week 12. And for week 12, in order to have that one, you need to make a forecast for week 11. You need to have that readily available before you can find it for week 12. For week 11, you need to know the forecast at week 10. And if you just go back, you will reach to week 1. This is, you see the chain of using the past forecast. Because of that, we have to stop this chain at some point. We have to have an initial condition. Usually for exponential smoothing, usually it doesn't have to be this way, but for most cases, we use forecast at T1 equal to actual value at period 1, or F1 equal to A1, F1 equal to A1. So that way you have a starting point, and then you can just come forward from week 1 all the way to week 13. And once you have it for week 13, you can use the same value for week 14, 15, 16, etc. All right, so let's just do that. So initial condition, exponential smoothing. The forecast for week 1 is going to be D equal to the actual value of sale at week 1, 17. So that's simple. And then let me just record alpha somewhere. Alpha, I'm just going to go with alpha equal to 0.3 as an example. But we can change it. Similar to K, you can change it and see the effect on your forecast. So alpha equal to 0.3 for now. So I have the exponential smoothing, the starting point for the procedure, and then exponential smoothing formula alpha. And I'm gonna use this formula. I'm gonna copy the formula so I'll make sure to fix alpha in my formula. Alpha times the actual value in one period before, actual value 1 period before, plus parenthesis 1 minus alpha, 1 minus alpha, again F4, just fix that value of alpha, times previous forecast. So once you have this formula, you're all set. You can just drag the formula down. You can drag the formula down. And of course, when you use this, you can change the value of alpha and everything will change accordingly. All right. So these are the techniques that we used when we were dealing with horizontal pattern. And for horizontal pattern, if you remember, we just need to identify the pattern, you just need to draw the line chart. And when you draw the line chart and when you add the trend line, whenever you see a horizontal, or approximately speaking, a horizontal line, then you should conclude that it's most likely a horizontal pattern, and we should use the techniques that are more appropriate for horizontal pattern, which include past average, moving average, naive, and exponential smoothing.